comes the functions. Functions are nothing but the sub-program which does a particular task. Okay, a function will also have multiple lines. It is a program of its own. Okay, and one function will perform one task, and the function can be called n number of times in your program. Okay, so the benefits of using this function is, obviously it's going to be reduction in the line of codes. Next, code reuse, we can reuse it. Next, it will be easy for maintenance and debug if you use your functions. So this is one example of your algorithm for your functions. For example, first you will declare your main function. First you will write about your main function. Start, call function, stop. Next, you have to define your functions. Functions start, get ABC, add A is equal to B plus C, return, print A and return. Okay, so first main function you will write, then the calling, the main calling of that function, that function you have to write. Okay, main program, then your sub program. This is how you should write an algorithm for your functions. Next is your notations. Notation means some symbols, okay, which we'll be using. First comes your flowchart. Flowchart is a graphical representation or a visual representation. There are some rules to draw your flowchart. First, the shape oval stands for start and stop, okay, for terminals. Next, the line in between are called as flow lines. You have a parallelogram for input and output, and for your processing, you have the process, that is your actual program where the computation takes place. You have to draw a rectangle. Next comes your diamond, which is a decision maker. So a diamond will have two flow lines coming out of it. Next, your connector. If you have multiple pages of flow chart, you can use this connector and connect your flow chart in the next page. And you also have this rectangle with another one line for your sub function. So this advantage of using a flow chart, it will be very easy to communicate, analyze. We can have a proper documentation. Efficient coding and debugging is possible. And disadvantage it, if we have a complex logic, no, it will become very clumsy. Okay, if we have a complex logic, it becomes very clumsy. An alteration, we have to alter the entire flow chart. Okay, if there is some error. Next, for reproduction, it will take time and cost. These are disadvantages of using your flow chart. Next comes your pseudocode. Pseudocode are nothing but they are short, readable, formally styled English language. Okay, but there is a difference between your algorithm and pseudocode. Here, there is no need to include variable declaration and subroutines, and program independent. This is program independent. No matter what language you are using, what programming language you are using, pseudocode remains the same. Okay, so it is program independent or language independent. Okay, but this is not machine readable. It is called a pseudocode. Pseudo means it is a false code. It is a code, but it is a false code. So you cannot compile and execute like your other programming language. Okay, so it is not machine readable and it is not compiled and not executed, and it doesn't have any standard syntax. Guidelines for writing a pseudocode. We have to write only one statement per line, and you can capitalize your keywords. Okay, and it has an index to hierarchy. You can try first, if you write a parent program, next you can write your child program. And if you have multiple structure, for example, if your for loop, while loop, for that you have to end it using end if or end for. Okay, that you won't be doing in algorithm, but here you have to do. Next, this is the statement we should keep language independent. The same pseudocode must be for other language also. That we have to take care. Next, the common keywords which we can use. Next is common keywords which we can use for your pseudocode. We can start with a comment. Okay, for comment you have that. Next, you can begin, end, input, get, read, compute, calculate, add, subtract, initialize, output, print, display, if, else, end if, while, end while, for, end for. These are the keywords which you can use in your pseudocodes. Example, this is one example of pseudocode for greatest of two numbers. So begin, read A, B. If A is greater than B, then display A is greater, else display B is greater. And for multiple lines, you should write a end if. Okay, end if, then end. And that is for the addition of two numbers. Begin, get A, B, add C is equal to A plus B, print C, end. Okay, so this is an example of your pseudocodes. The disadvantage is it is not a visual representation like your flow chart, and there is no accepted standard for your pseudocode. Okay, and since it's a pseudocode, it cannot be compiled nor executed, and for a beginner it will be more difficult to write pseudocode, okay, while compared to your flow chart. Okay, so the